1.4, continuity and one-sided limits. This is part C. So we have a new theorem, intermediate value theorem, or I'm probably just going to be writing IVT, and you're allowed to do that. If f is continuous on the closed interval from a to b, so if it's continuous, which means there aren't any breaks, and whatever the y value for a is not the same as the y value for b, then the k is any number between f of a and f of b, then there exists at least one number c in the interval a, b, such that f of c equals k. Okay, so now English. They're saying that if I have a continuous function, and as long as this height, which we're going to call f of a, right, our y value, is not the same as this height, right, for b, which we're going to call f of b, so that's our y value for b, then there is a number that we're going to call k somewhere in here. Don't really know where, right? We're just going to call it k. And k is going to belong to an x value that has to be in between a and b. And that's what it's saying. So like, let's say k was right here. Let me get rid of that. Okay, so k is right there, right? So then here is where I would find my c. Oops. Let me make a prettier c than that. I can get rid of that. So there's c. Okay, so that is, it's actually kind of common sense, but this is an official theorem. It's the idea that in order to get from one place or one section, basically here, in order to get here, I have to go through all of these numbers. I mean, there is no, oh, maybe I skip a number. If it's a continuous function, in order to get from a to b, I have to pass through all of the points in between at some x value. So this is the intermediate value theorem. Intermediate means in between, right? So we must pass all of those points. I can't have, let me draw a graph. Here's my makeshift graph. So let's say I have a point here, and then a point here, right? And okay, so if I start at 1, right? My x is 1, and so like my first point here is 1, 2, right? This is a height of 2, and then here I have 5, and then this height is 4. Well, in order to get from 2 to 4, I have to pass by 3. Okay, I'm not just going to miraculously have a graph and I'm going to go and, oh, no, 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 let's skip 3 and go to 5. Yeah, this could happen, right? We have holes, but the thing is, in order for this theorem to work, the function has to be continuous, so therefore the hole won't work. Okay, so now we're just going to put it to use. Example 1, does the intermediate value theorem, or IVT, apply to the interval from 0 to 3 to get a value of fc equals 4? So, in other words, is my function f of x, right here, is this, at some point, does this function equal 4? And if so, the x value at which it does equal 4 is that x value between 0 and 3. So, easiest way to do this is to take your function, because it says if so, find the value of c guaranteed by the theorem. So this theorem guarantees the existence of an x value, but doesn't give it to you. So you have to actually find it by doing the math. So x squared plus x minus 2. So we're looking for it, and while we're looking for it, we're going to go ahead and check at the same time. So the idea is that this function at some point, for some x value, it should equal 4. Or at least, rather, we're trying to check to see. Now checking and finding are two different things. Here we have to find the x value, which they're referring to as c. So I'm just finding it because that's a good way to check and find at the same time. But to check, the way to do it is to take your function, and I'm just going to take a break from this right here. So our function, right, you plug in the first part of the interval, the endpoint there, and then you plug in the second part. And then you see what you get. Oops. Let's erase that. You see what you get. So I plug in 0, and I get 0 plus 0 minus 2. And then I plug in 3. Let me make that blue. I like color consistency. Minus 2. Okay, I plug in 3, and I get 3 squared plus 3 minus 2. So let's see, 9 plus 3, so that's 12, minus 2, so that's 10. And then the idea would be, okay, these are my y values, and in order to check to see if my c value is just even guaranteed to be there, right, would be, all right, what's the number that this was supposed to, oh yeah, it was 4. Now, is 4 in between -2 and 10? And yes, it is. So this right here, this part alone is telling me, yup, there should be a c. Now this is checking to see if there is a c value, a guaranteed c value, which is x. Now the stuff I'm about to do on the left side, that's actually trying to find what the c value is. Okay, that's why I said there's a difference between is there a c value, finding it, or sorry, is there a c value and finding it? Because sometimes you have to find it and sometimes you have to just check. Alright, so on the right side, I just did the checking. On the left side, I'm going to actually go ahead and find it. So easy enough, subtract 4, subtract 4. Now I have x squared plus x equal, or sorry, minus 6 equals 0. So if I want to figure out what x is, in order to find my solutions, I'm just going to factor. So see, I need two numbers that multiply up to -6, but that add up to 1, right? Because this is the number right here is 1. So I have 3 and 2, they multiply, but for the 1 to be positive, the 3 would have to be positive. So there you go. So x equals, or the solution here for x is either -3 or +2. Now remember, we did figure out that yes, it is guaranteed that there is a c value. Now we're trying to figure out what the c value is because it did say, if so, find the value of c guaranteed by the theorem. Okay, so I have to check my interval. And the reason for that is, oh, I've made a mess of my interval, but, okay, my interval says that x has to be between 0 and 3. Well, checking my solutions, -3 is not in between 0 and 3, but x equals 2. 2 is definitely between 0 and 3. Okay. Example 2. Assume that f is continuous on the interval 1 to 5, and that f of 1 equals 20 and f of 5 equals 100. Determine which of the following statements must be true for c, being an element of 1 to 5. Okay, so in case you didn't know what this means element. An element just means it's part of that set or that group. So 1 to 5 is the interval. So c is in between, or it's at least 1 or 2 or 3 or 4 or 5, or a number between 1 through 5. So when you see that symbol, I need you to know what that means. It's algebra 1 stuff. So again, assume that f is continuous. So this function is continuous. So there's no holes, no gaps, no jumps. And it's continuous from 1 to 5. And sometimes I feel like it's really helpful to just do this horrible little sketch of somewhat of what this graph might look like, because it might help. So let's see, when x is 1, y is 20. So here's 1, let's call this 20. So right there. And then when x is 5, y is 100. So let's call that 5, and let's call this 100. Okay, so let's say it's something like that. Now, it should be obvious at this point that since it's continuous, my y values, right? The smallest one is 20, and the biggest one is 100. So that means that if, right, because we're checking for the IVT here, it didn't say intermediate value theorem, but that's what we're doing. So if I want to get from 1 to 5, and I'm starting at 20, I have to move up to 100, right? So um, my y value has to be between 20 and 100. I'm not going to skip from 30 to 45 because this is a continuous function. So 20 is in 21, at some point is in 22, 23, 24, etc., all the way to 99 and then 100. Okay, so I'm just basically breaking down what is being said here. So it says determine which of the following statements must be true. Now this word is really important. Must means always. It is always true, not sometimes. Okay, so that's really important. Must is something that always happens. It can't be it can't be true in this case, right? If it's a must. If it's only sometimes or maybe or it's a possibility. This is not multiple choice, by the way, so we're going to go one by one. Okay, so A, it says f of c equals 3. All right, so if f is continuous from 1 to 5, um, can my function equal 3 at any point between 1 and 5? And hopefully if you paid attention to what I was saying about what my y values could be, you should see that no. Okay, 3 is down here somewhere, right? So I don't really know that my function ever goes that low. Now, can it? Yes, it can. My first graph that I drew here, it doesn't. My graph here does not go down to y equals 3. But could it have gone down like this? Yep, it sure could have. But see, I don't know if it did for a fact. So there's like an instant where, yeah, f of c equals 3 could happen, but then there's also an example of, nope, maybe it didn't happen. So that's not necessarily a must. So this is false. Okay. Now, B. Should there be an x value where my function, my graph, reaches 75? Well, let's see. 75 would be up here somewhere. Now, is there any scenario where from getting from here to here that I will not be forced to pass through 75? Is there any such graph that I could possibly draw that will not force me to pass through 75? 75 would be right under 100. And hopefully your brain's like, no, of course not, duh. This is continuous. We can't skip over numbers. So B is true. And then if you pay attention to C and D, they also fall under the same exact rule. Because 75, 50, and 30, all three of these numbers are in between 20 and 100. So these are all true. So this could be a multiple choice question, but the question would be determine which of the following statements is not true. And then your answer would be A, for example. Example 3, an object falls at a continuous speed, s of t. The table below lists the speeds s in feet per second at various times t in seconds. Do the data in the table support the conclusion that the object's speed is 25 feet per second at some time t, with 0 being less than t being less than 30? Give a reason for your answer. Okay, so this is my interval, right? These are my x's. And they want to know that if this data actually supports a conclusion that the object's speed is 25 feet per second at some time. Now, if you look at the table, right, the smallest time interval, the speed at the smallest time interval, which is 0 right here, is 0. Now, the speed at the biggest time interval, let's see, biggest, which is 30, the speed then is 56.3. So the question would be, if I go from a speed of 0 all the way to a speed of 56.3, and this is a continuous function, right? Then I must pass through 1, 2, 5, 15, 20, 25, 30, 33, 39, 45, etc., right? I must pass through 25. And since 25 is actually in between 0 and 56.3, then yes, according to the IVT, there should be a time where I'm guaranteed to have a speed of 25 feet per second. So I'm going to go ahead and write out how the answer should look, and you should copy that down. All right, so this is somewhat what your answer should look like. You could say yes, right? Because it was a question, it was asking if the data in the table supported the conclusion. So yes, S of t is continuous from 0 to 30, right? That was given to us. And since 25 is between 0 and 56.3, and then if you have this written down right here, then they'll know where you got that from. The IVT guarantees a value t such that S of t equals 25. Now this is an example of an FRQ type-ish question. All right, last example. A scientist, which is very similar to the previous one. A scientist measures the depth of the Doe River at Picnic Point. The river is 24 feet wide at this location. The measurements are taken in a straight line perpendicular to the edge of the river. Notice how this is all just gibberish. You really don't need it. The data are shown in the table. Do the data in the table support the conclusion that the depth of the river is 10 feet at some distance from the river's edge? So in between 14 and 22. So we're looking at this right here. Give a reason for your answer. So do I know for a fact from this data, can I use the IVT basically to know that yes, in between 14 and 22, this river might definitely, not sorry, I didn't mean might, definitely is 10 feet deep. Okay, so to start off, our lowest, what you call it, feet distance, our lowest distance is 14, and our highest distance is 22. So let's call this f because they didn't actually formally give this any function and name. So f of 14, according to the table, our depth is going to be 8. And then f of 22, according to the table, that depth is 2. Now, they're looking for 10 feet. Now, is 10 feet in between 2 and 8? It certainly is not. Okay, 10 feet is not between 2 and 8. Is it possible that between 14 feet from the river's edge to 22 feet from the river's edge, is it possible that yes, this water level actually did go up? Let's say 16 feet. Is it possible that the depth was 10 feet at 16 feet from the river's edge? Yes. But am I certain? No. Okay? I don't know for a fact. So since 10 is not between 2 and 8, I'm going to have to say no. Was it a possibility? Yes. But I need to know for certain. Okay, so I'm going to write down the answer. All right, there's my answer. No. Although depth is continuous from 14 to 22, or sorry, I meant to say distance. Well, depth too. Although this function is continuous, basically, 10 feet is not between 2 feet and 8 feet. Another way that I would have written that, give myself more space, would have been to say that 10 is not an element of 2 to 8. Okay? So try very much answer your homework problems. See you in class.